Okay. We are looking at lesson 1.7. I know it doesn't look like it says 1.7 up there, but I promise it does. Just pretend, okay? Just pretend. 1.7 is modeling with functions. Okay? And there, now you can see 1.7 online a little bit. When we talked about modeling with functions, okay? Using formulas here. Using formulas to represent situations, to solve problems, just, you know, a little bit about everything here. So we'll look at some various different ways we can discuss functions. So example 1, write the area of a circle. And then we're going to do this in 3 different ways. So we're going to write the area of a circle in 3 different ways. We're going to write the area of a circle on part A as a function of its radius. So we're going to write the area of a circle where it uses radius in the function. Then on part B, we're going to write the area of the circle, but instead of using radius, we're going to base it off of diameter. And then on part C, we're going to write the area of a circle, but instead of basing it off of radius or diameter, we're going to base it off of circumference. Okay? All of these, my area is my output. It's a matter of we're changing up what the input is. Now, part A. The area of a circle as a function of its radius. Okay, guys, your pre-cal level. What do you know here? Area of a circle.
Pi r squared.
Pi r squared is what you should know at this level. You've been learning that since middle school, if not elementary, right? Uh-huh. Definitely middle school.
That was hard.
You guys are juniors and seniors now, so.
I didn't do elementary.
Okay. So maybe you didn't learn it in elementary, but now on part A, we're done. It said to write the area of the circle as a function of its radius. So that means write an equation that is area equals, and the input value is r. So that was just knowing the formula. No work to do there. Got it? Okay. Part B. I obviously hit the wrong thing as I'm writing nothing here. Okay, part B, I want it in diameter. So the formula we know uses radius, correct? We're going to take this formula and we need to adjust it. Now, can I just say area equals pi times d squared?
No.
No, because that's not equivalent, right? We need to make it equivalent.
Make it equal to r.
So what do we know about r and d?
Radius is half of.
Okay. Radius is half of diameter?
Yeah.
Correct? I mean, you can say it either way. You can say, my brain always starts here. My brain always starts at 2 times the radius is the diameter. But honestly, more helpful is going to be Emma's comment that radius is half of diameter. So you can say 1/2 d, or you can say d divided by 2. You pick, right? So now we're going to use this formula here. A equals pi r squared. So area is pi. What am I putting in for radius, though?
1/2 d.
1/2 d, d over 2, quantity squared. Does that make sense? I took r. It was supposed to be r squared, but instead of r, we know that the radius is the diameter divided by 2. Now, can we clean this up a little bit? What is d over 2, quantity squared?
D squared over 4.
Okay, we could write it as d squared over 4. How did I write it in my final answer? We honestly could leave the answer like this. There's not just going to be one right way. If we think about putting our constants out front, I mean, we could think of this as when I multiply by pi, pi is pi over 1, correct? So I could do pi times d squared over 1 times 4. So you do pi d squared over 4. Or what I think I tend to say is pi over 4 times d squared. Any of those would be equivalent. Okay, so there's not just one right answer here. Any of these, like last three, any of these really are equivalent. So,
They're bit complicated, but
okay. And now for part C. I'm going to go up here so I have more room to work. Part C wants us to write the area, but in terms of circumference. Okay, so dig in those brains. What do we know about circumference of a circle?
Is it 2 pi? No.
Circumference is 2 pi r?
Plus 2 pi r h.
No. Stop there. We're done.
No, you're getting
Going way too far.
That's AP bio, isn't it?
Yeah, you're getting
Yeah.
into surface area.
I was just going to say, you're going to surface area, and I'm just basic area here, okay? So, circumference of a circle is c equals 2 pi r or pi d. Now, which one's more helpful? Probably the 2 pi r, because what's our original formula in? It's with an r, yes? So now, if we're going to plug in for r, we need to know what does r equal in terms of c. So how do I solve for r here? Divide by 2 pi, if you will. And so then r is equivalent to the circumference divided by 2 pi. So you know that area formula from part A? A equals pi times r squared. What am I putting in for r? C over 2 pi, quantity squared. I mean, technically, in a way, you can leave it like this. I would clean it up a little bit. Okay. What is pi as a fraction?
I don't know.
What is any number as a fraction?
I have 1.
Put it over 1, yes? Now, c over 2 pi squared. Well, if we actually square this, c squared, or c and then squared is going to be c squared. What happens when you square 2 pi?
4 pi?
No. 4 pi squared.
Okay. 2 squared is 4. Pi squared is pi squared. It's not a variable, but you can write it in terms like a variable and said pi squared. What can I clean up here?
Pi.
1 pi on top can cancel with
1 pi.
one of the pi's on bottom, so I'm just going to cancel out the exponent, if you will. Because a pi squared, one of them cancels, we're left with pi. So I could write this as c squared over 4 pi.
Interesting.
Is that how I wrote it in my answer? Yeah.
Interesting.
Okay. There are times where there's importance to being able to take a formula we know and, make it so that it's useful for us. If you're provided, the circumference and you need to find the area, well, here's an option. Okay, the other option would just be trying to find the radius and then plugging the radius in, but there's an option. Okay? Okay. Example 2. A square of side x inches is cut out of each corner of an 8-inch by 15-inch piece of cardboard, and the sides are folded up to form an open top box. Write the volume of the box as a function of x. Okay. What? Okay. A square of side x inches is cut out of each corner of an 8-inch by 15-inch piece of cardboard. Okay, guess what that is?
8-inch by 15.
That is my 8-inch by 15-inch piece of cardboard. Easy enough?
Sure.
I mean, I got what? When I was suggested we do this problem, so I've got to get us started, right? Okay. So each corner of an 8-inch by 15-inch piece of cardboard, a square of side x inches is cut out of each corner. So the idea here is that a square is cut out of each corner. And what do we know about each of these squares? X inches. And so if a square is x inches on one side, it is x inches on the other side, right? So each of these squares that it's being cut out are squares that are x by x long, x by x wide, however you want me to say that. Okay, so we have this piece of cardboard. We're going to cut these squares out, and then the sides are going to be folded up to form a box, right? Are we seeing what's going on here?
Oh, yeah.
Corners are gone.
Yeah.
You fold up the flaps then, because basically you have a flap on each side left. Fold them up, we have a box. We want to know the volume of that box. But we want to know the volume of that box in terms of x. Okay, what's your brain say about volume of a box?
Don't you have to find like the
What's volume?
Length times height times width.
Okay. Length times width times height is our volume of a rectangular prism, if you want to get officially, official language, but volume of a box is length times width times height. Now, the deal is we don't want to say length times width times height. We want what is the length in terms of x? What is the width in terms of x? And what is the height in terms of x? That's what I'm looking for here. Okay. Thoughts on any of these? We will. Let's talk about the length and the width first.
Well,
usually you just
minus x, it would rise 2x.
Okay, so
15 minus 2.
okay.
And
Minus
then 8 minus 2.
Okay, good. You guys are seeing it. So I'm going to switch this 15 because I want to use... So if this whole length is 15 inches, yes? And what we want to know is that length right there, yes? The whole length is 15. What are we taking off of each side? X. So it's 15 minus the x on one end, minus the x on the other end, and thus my length is 15 minus 2x. Are you seeing how this also works with width then? If the width of the whole piece of cardboard is 8, but then what are we doing? We're taking off x and x. What is that flap that's left? 8 minus x, so 8 minus 2x. So at this point, I have volume equals 15 minus 2x times 8 minus 2x times the height. I was told we don't have the height, but we do. The height comes from where? These little flaps I'm folding up, yes? And how tall are those flaps I'm going to fold up? They are x, yes? So that makes my height x.
Simple.
Now, we have options. We could FOIL this and distribute it all together. Or, depending on what they want, you could leave it like that. I have it like this in my notes. If they want it multiplied out, obviously, you would multiply it out, right?
Yeah.
Ew, no, I don't want to multiply it. I was like, oh, I'm going to multiply it out.
Well, and here's the deal, guys.
Multiply all of them.
If you multiply it out, you have to FOIL these two and then distribute the x in the end, was what I would say. And I'm getting my visual clues that is a good stopping point because
We have a minute.
the bell's about to ring. So we will pick up tomorrow, and that will make 1-7 homework due on Thursday.
Oh no.
And then does that mean Friday we'll be getting